This is going to be a really quick little video all about inflection points. So we're going to call them IPs. So an inflection point marks where the concavity of a function changes. So for example, if we have something like this, I know that just looking at this whole piece is concave down, and then it looks like, just to my eye, that right about here the concavity changes. So the inflection point would be right here. Alright? That's the concavity change point. It is neither concave up nor concave down. Alright, what if you want to figure out where that point is? What you would do is you would take the derivative. So you would say that happens at f prime prime of x equals 0. Take the second derivative of the function, set it equal to 0, solve for your x. You will then get the x where this happens on the original function. To get the y, take that x and plug it back in the original function. This is what the original function looks like. That will get you the y. So that's a little something about an inflection point. Let's talk about one more thing with inflection points and how I can spot them. So if you have one curve, alright, so we'll do the traditional one. That's the easiest one to deal with. Here's my curve. That's the function f of x. If I'm going to do the derivative of that curve, I look and see where the slope is 0. That gives me the roots of the first derivative. I then look for the inflection point, which looks like it's around here. Because it's negative, that gives me the minimum of the first derivative. Here's my first derivative. Okay, as f prime of x. Make that just 1 prime. Okay, let me just do this and we'll fix this up for us. Okay, so this is f prime of x. Alright, so what do you know about an inflection point? Well, the inflection point on the original curve, which is right here, is where it changes concavity. You can spot the inflection point x value on the first derivative because it is the minimum of the function. Let's draw the second derivative. So we'll do the second derivative in a different color. And what do I know? I know that the second derivative is the slope of the first derivative. What do I know? I know this was my minimum. Since that was my minimum, that is going to be the 0 right here. That'll be the 0 of your second derivative. The second derivative looks like it's going to be a line because the first derivative was a parabola and the original function was a cubic. Okay, so the question is, which way does the line go? I know only one point. So then you look at the original function and look at that concavity. If it's concave down, which it is, from here to here, then that means that my my slope value, will be negative because, remember, if it's concave down, if it's concave down, then I'm going to have a negative value. So where do the negative values happen? They happen below the x-axis. The other section is concave up. So all here, this is concave up. Concave up means that the slope values of f prime prime are going to be positive. Okay, let me get rid of that again. So this green graph right here is f prime prime of x. Okay, so that was a couple of little things about the inflection point and how the functions relate. The notes are very good on that also, so look at the YouTube for the two notes and look towards the end of it and you'll get more information.